transformations to graph quadratic functions. When we're talking about the different translations, or the different transformations, the first one we talked about in chapter 1 are your translations. If you have a function, and we're just going to say f of x equals x squared for the entire chapter. If we have f of x minus h, what happens is we're going to, if h is less than 0, it's going to take your parent function and move it to the left. If h is greater than 0, it's going to take your parent function and move it to the right. If you take the actual function and you add k to the outside, that is going to move it up if it's positive, down if it's negative. With our parent function of f of x equals x squared as a guide, we're going to describe the transformations and graph each function. We have g of x equals the quantity of x minus 2 squared plus 4. We first need to identify h and k. Looking at this function, what is h? Where do you find h? H happens inside the parentheses. So it needs to be x minus h. So what's your h here? 2. H is 2. What is your k? 4. What this means, 4 because you have the 4 out here. What this means is you're going to take this and horizontally shift it to the right 2 and up 4. So if we have our parent function here, you take this and you move it to the right 2, up 4. Your new graph would look like this in comparison to the parent function. Looking at the parent function, now I have g of x equals x plus 2 squared minus 3. Remember, it has to be x minus h squared plus k. But what's here? Plus. What would make a negative a positive? A subtract, another negative. So it would be negative 2. What is your k? Negative 3. When you're inside the parentheses, you think opposite of what's written there. If it's positive, you want the negative. If it's negative, you write the positive. So if we have our original parent function, I'm going to shift it to the left 2 and down 3. Your graph would look like this. For this one, we have the parent function x squared. We're talking about g of x equals x squared minus 5. When I asked you to find h and k, you know what k is, right? What's k? Negative 5. It's the h that's giving you an issue. Where do you find h at? In the parentheses. There is none, but there technically is. There's technically ones around the x. What is in there with the x? Nothing. Mathematically, what do we call nothing? H is 0. There is no shift left or right. We don't move it left or right. We're only moving it down 5. So we take the original function and shift it down 5. There you go. We've talked about the translations. Then there's the other 4. The other 4 we talked about in chapter 1, we have our reflections. Reflections over the y-axis, you put what's on the inside of the parentheses negative. A reflection over the x-axis, and this is the one we're going to talk about the most, which where the whole function is negative. Stretches and compressions. Horizontally, it will stretch compress by multiplying the x by a factor of 1 over b. So if they tell you your factor is 3, you need to change it so it's 1 over 3. And the vertical stretch or compression, this is where you take the x squared, the entire function, and multiply it by scale factor. All of the stuff we talked about in chapter 1. I have the function x squared. We're going to look at the transformation of g of x equals 1/4 x squared. Now, that number that is multiplying, bless you, is that inside the parentheses or outside? Outside. When you have a multiplier outside, it is a vertical stretch or compression. If it was like this, it'd be on the inside. So it's on the outside. Your factor is 1/4. Now it's hard for me to take it and manipulate it 1/4 this way, so I'm going to do it on the calculator. We'll put our parent function, and the second one's 1/4 x squared. I'll make mine darker line. There's the first one. 1/4 x squared. What this is saying, it is vertically stretched or compressed by 1/4. When it's less than 1, when it's between 0 and 1, it compresses toward the x-axis. If it's greater than 1, it stretches away from it. So because it was a 1/4, it has now taken the graph and pushed it downward. It opened it up. If you push something down vertically, it is going to stretch it horizontally. Questions? Here I have 3x squared. Is my factor in the inside or the outside? On the inside, this is what we're looking at, horizontal. The difference between horizontal. This one, the factor is 1 over b. So 1 over b is equal to 3. We know that the factor is 1 over b. Take the reciprocal of both. The b is 3. So if I type it in the calculator, this one stretched it horizontally by a factor of 3. Now, if you have a parabola that opens upward, so you have a parabola that opens like this. This is its lowest point. We call that lowest point the minimum. If a parabola opens downward, that is its highest point. We call it the maximum. That point, max or min, is called your vertex. In Algebra 1, we talked about all the different linear forms. Slope-intercept form, point-slope form, and standard form. When we're talking about quadratics, one of them is called vertex form. Vertex form is what we've been talking about in this first section. A times quantity of x minus h squared plus k. This pretty much puts everything together. If you have a number out front, That is going to be your stretch or compression. If it's negative, it will be a reflection across the x-axis. X minus h. This is going to tell you the horizontal translation. And the number that's on the outside by itself, a constant, is your vertical translation. The vertex of the parabola is always by the point hk. If I have a parabola, the vertex, in the parent function, I'm going to move it to the right 3 up 2. I move it to the right 3 up 2. The vertex is now at 3, 2. And that's what would have been in here, 3 and a 2. So we have our parent function x squared trying to vertically stretch it by a factor of 4/3, and then translating it 2 units to the left and 5 units down. Remember that vertical stretches are A, the stretch compresses are A, the horizontal translations are H, the vertical translations are K. What is your A value? 4/3. How would you write H? What's to the left 2? -2. 5 units down would be -5. So g of x is equal to, A is 4/3, x minus -2. Instead of writing x minus -2, I just changed to x plus 2 squared minus 5. And there's your new function. When comparing the two here, you see that the number out front is the only thing that changes. So it's a vertical stretch or compression. Is the number getting bigger or smaller? We're multiplying by a smaller number, right? If you multiply by a smaller number, what is happening vertically? Smaller is not an answer. Is it stretched or compressed? Compressed vertically, and then we'd have to find the factor.